I've been working in the industry for over 20 years and working with big, small organizations to modernize their cloud and AI platforms. Excited to be here talking to you about MCP. So in this session, we'll talk specifically on how MCP or Model Context Protocol enables AI agents to securely and seamlessly integrate with external tools, APIs, and services, which extends which extends these AI agents far beyond what they can do as like for basic chat or automation scenarios. So MCP is to kind of give our AI agents those superpowers. So I would like to make this session half and half where roughly the first half of the session will be presentation based. So I'll walk you through my PPT. I'll give you details on what MCP is, why it matters, how it works, and how it integrates with Azure API management, because that's kind of our Microsoft's central tool to create your own MCP tools and to support enterprise-grade security, governance, and scale, in addition to giving you that capability to create these MCP tools. So it also supports security at scale. And then in the second half, I'll switch to a live demo. I'll show you step by step how to spin up an MCP server using Azure API management, how to connect it to an agent using Microsoft Foundry UI, and also how to consume the same MCP server directly in code using Visual Studio Code. So my demo would focus both on UI, how you can do it within Azure API Management UI, and Foundry. And then I'll also show you some examples of how easy it is to consume these MCP servers in a code where I'll be using VS Code. Overall goal is to make this very real, very practical, to show you how easy it is to create, deploy, and consume MCP servers both through UI-based experiences and through code. And for questions, if you have any questions, please drop them into the chat while I'm going through the presentation and the demo. And as long as we have time at the end of the session, we'll go through those questions live. And if we run short on time, feel free to reach out to either Derek or me. I will give you our details, and we'll make sure that your questions get answered. All right, with that, let's dive in. And before we get into MCP, I'll start by grounding what we mean by an AI agent. I mean, this is important for us to understand before we go into MCP, because once we understand what's an AI agent and what are some of the problems that we are trying to solve, that'll set a good ground for us for MCP. So an AI agent is more than a chat model responding to text. I mean, that's how it all started. But today, agents are way more powerful than that. An agent, it's a system that can reason, it can decide and act using tools. In this slide on the left, you see we have inputs that an agent works with. So this is just a single prompt. An agent continuously receives like system events, which are things like timers, triggers, or external signals. It receives user messages, which are what a user asks or requests, can include a prompt. And then agent messages, which are its own internal reasoning or previous steps. And together, all of this creates an ongoing stream of context, not just a one-off interaction. This is what agent is getting from these input sources. And then in the middle, you see the agent itself. An agent is made of three things working together, as you see here. LLM is the reasoning engine. It understands intent, it plans steps, and decides what to do next. And then instructions define an agent's role, its goals, boundaries, and behaviors. And this is why the agent behaves consistently. So that's where instructions are important. And then finally, tools are what makes the agent powerful. And that's going to be sort of focus of this session where we'll talk about MCP. Without tools, the model can only talk. With tools, the agent can do things. So that's why I said earlier, tools or MCPs what gives our agents those superpowers. And then on the bottom here, you see tools, which are the bridge between reasoning and action. So tools allow the agent at a high level. These allow the agent to look things up, which is what comes under knowledge, take real actions using APIs, workflows, etc., and store and retrieve state represented by memory here. Now, the important thing to understand is this. The model does not execute tools directly. So that's a very important distinction to keep in mind. Model decides when and how to call them. That decision-making loop, think, act, observe, think again, that's what ultimately makes our agent whole. I mean, that's what makes it an agent. And then closing this slide with what you see on the right is these are the outputs. So an agent doesn't respond with just text. It can produce agent messages such as explanations, summaries, and next steps, tool results, which are real outcomes from systems like databases, CRMs, ticketing tools, or APIs. So the final output reflects both reasoning and real-world execution. All right, so that's what an agent is. And now that we know what an agent is, and in today's world, I mean, going beyond being a simple chat tool, we know that modern AI agents, they rely heavily on tools. Tools are how agents take action, access data, and create real value. But once agents start using a lot of tools, I mean, you might start with one or two, but in an enterprise, once our agents are using multiple tools, new problems appears. And it's what we call unmanaged tool endpoints, or in other words, this is the M by N explosion, and I'll talk more about it as we move forward. So unmanaged tools, they don't just slow down the teams. They create real security challenges. They create compliance challenges and a lot of operational risk, especially when enterprises scale. There are multiple other challenges, as you see here in this slide. Teams are re-implementing same integrations over and over, leading to too many tools, often duplicate, or what we call the classic M by N integration problem. So this is a big challenge when you're using multiple tools in a big organization. Another one is where without a standard trust model, agents can be pointed to spoofed services, compromised endpoints, or unvetted tools, which create serious impersonation and data exposure risk. The next one, most tool integrations today require API keys, tokens, or secrets. And if any of those leaks, it's not just a tool at risk, it's the entire backend system. So that's what you see here, the risk that comes under exposed credentials. And then agents can bypass enterprise policies entirely. Teams plug in new endpoints without security review, leaving security teams, compliance teams, and platform teams totally blind. And then last one that I would like to talk about here is there's no single place to answer what tools exist in the organization, or who owns them, or who's making them, which makes discovery, reuse, and life cycle management almost impossible. So these are some of the challenges. I mean, again, I'm trying to set up our problem statement that the challenges that enterprises are facing with multiple tools. And that's why big companies, they need that one trusted layer to sit between agents and tools. A single layer that standardizes how tools are exposed. It secures how agents connect. It governs access and usage, and it makes these tools discoverable and reusable. So without this layer, agents simply don't scale, and they don't scale safely. And that layer is MCP. Oh, so MCP, or Model Context Protocol, uh, it standardizes how these AI agents they discover and use enterprise tools and data. And this is going to be the focus of our session. Uh, One thing I would like to emphasize here, standardizes. So MCP is not a product, it's not a platform, and it's not a framework. It's a protocol. Uh, so MCP is that missing adapter we talked about earlier. So this is what sits between our agents and tools. It's that consistent and governed contract. MCP defines how tools are described, how agents discover them, how calls are made, and how results flow back safely. Another way to define MCP is that it's that universal language that lets AI agents talk to different tools and data sources in a consistent way. So instead of custom connectors or custom APIs or one-off integrations, MCP gives our agents a standard protocol for discovering and using whatever systems your organization is relying on. Moving on, I'll present a few more ways you can describe MCP. I mean, just more intuitive ways to explain what MCP is and what it can do. So another way to define MCP is you can put it backwards, which means starting with the P. So it's a protocol for providing context to models. That's one definition I always love. I think it explains it beautifully. Or another way to define it is it's the universal cable, or USB-C, to make our agents talk to different tools. So it's that one universal adapter. Another analogy that I love to use is uh, agent. Look at your agent as a chef, and then MCP server, MCP tool is that kitchen. Uh, and then the tools and resources that MCP is going to talk to are the stove, knives, ingredients that uh, once the chef decides what he wants to cook based on a request, the kitchen or MCP servers, it provides those trusted tools and ingredients to make it happen. What MCP is not, to be very clear, it's not an orchestration layer. It's not providing that orchestration between multiple agents, because the systems today, AI systems today, are growing, and it has become very common to use multi-agent systems. So it's not the orchestration layer. It does not tell the model what to do. That's model itself, and then it does not replace APIs. APIs is what MCP facilitates and makes your agents talk to. Oh, so now that we have defined MCP at a high level, let's break it down into its core building blocks and how they fit together actually. Starting at the top left, we have the MCP host. So host is the AI application itself, which could be a chat interface, an IDE like VS Code, or an AI-powered application running in production. So that's your host. And host is what owns the user experience and the model, but it does not directly manage integrations. Inside the host lives the MCP client. So that's the second part. Client is a component that actually speaks MCP. Client has three primary responsibilities, which map directly to the primitives that I'll just touch down upon. It queries for resources, it invokes tools, and then it interpolates prompts. The important point here is a separation of concerns. So agent is what is doing the reasoning. The client is communicating, and protocol keeps things consistent. So that's a good way to define these different components. And then transport that you see between the client and the server, it happens either locally via standard input-output or remotely over HTTP using server send events. So these are the two primary protocols that MCP uses. And then on the right is the server itself, which is where enterprise capabilities are exposed in a controlled and standardized way. So the server exposes resources, it exposes tools, and it exposes prompt templates. Server can front APIs, it can open databases, it's basically a front to databases, file systems, or internal services. MCP is not replacing those systems, it only makes them agent ready. And here we see some of the primitives that are part of those core building blocks for MCP. So the first one is tools. So tools are functions that the MCP server exposes and the client can invoke. Examples include retrieving or searching data, sending a message, or updating database records. The key rule is model decides when a tool should be called, but the tool executes outside the model in a governed system. And then next are resources, which are read-only data or content exposed by the server to provide context. So examples are files, database records, and API responses. And then finally, prompts, which are server-defined templates that guide how agents interact with the model, such as it can be document Q&A, transcript summarization, and forcing structured output like JSON. So these are the three primitives, what we call tools, resources, and prompts for MCP. Moving on, so what we have seen so far, let's try to put it all together. So how does it all comes together at runtime? So step one is where agent is configured to use one or more MCP servers. We are declaring which servers the agent is allowed to interact with. So that's the step one. And then step two, when the agent starts up, MCP client initializes the connection to the server. At this point, the agent asks the MCP server, hey, what capability do you expose? And then MCP server responds with a list of, or a structured list of tools, along with their descriptions, input schemas, expected outputs, etc. And then step four is where the LLM reasons over the tool and tool metadata, and it decides which tool to invoke. And if any, this is where the reasoning happens. And then finally, agent invokes that selected tool on the server, and the server returns a result from the tool. And this can then go in a loop where it can go into that continued reasoning or a final response. All right. Moving on to, so far we've talked about MCP, I mean, at a high level, what are the core building blocks? Now I would like to talk about how MCP is being implemented at Microsoft. So within Microsoft, MCP is deeply integrated across Microsoft platforms. It came into being what more than a year ago, but within the last year, Microsoft has added or done integration, MCP integrations into all of their tools in a big way. So what you see on the left, Azure Foundry Tools, Azure Logic Apps, Agent 365, and GitHub. All of these have been exposed. I mean, some of these are new things that were introduced at Ignite, but all of these have been already exposed as MCP servers. So this means customers can leverage existing Microsoft services, or they can create new ones as standardized endpoints for these agent workflows. But then you're not only limited to what's provided by Microsoft. You can build your own MCP-enabled tools using API Center, functions, Azure Logic Apps, App Service, container apps, and more. And this is one of the things that I'll show you in my demo later on. And then on the right, what you see, these are the MCP clients. So within Microsoft ecosystem, Foundry, Agent Service, Copilot Studio, VS Code, and GitHub Copilot, these can all invoke these tools seamlessly. I mean, Microsoft tools or your custom tools that you have created, they can all be invoked seamlessly while security and governance are built in with Azure API management and Entra ID. So that's a key. Security is always baked in, and in this case, we use Azure API management and Entra ID for that identity and access control. Right, moving on to some best practices and security consideration. I mean, now that you know what MCP can do, the capabilities, how it's implemented within Microsoft ecosystem, I would like to point out some of the best practices here. So on the design side, first, treat MCP servers like real services, which should be owned, documented, versioned, and monitored. Second, clearly separate resources which provide read-only context from tools that mutate systems or that go beyond read-only. I mean, they're changing state of other tools. And third, instead of exposing dozens of low-level API calls, expose meaningful business actions and things a human would reasonably ask for. That's a good framework to define these API calls or what calls should be exposed. It simplifies reasoning and reduces the chance of unintended behavior. I think that's key here. And fourth, use prompt templates to standardize sensitive workflows, which ensures consistent behavior is happening across agents and they're providing safe outputs. And finally, build once, reuse everywhere to avoid the end problem, which is one of the key problems MCP was designed to solve. Security and governance considerations on the right, these are pretty self-explanatory, but I'll emphasize the last one here, which is enterprise policies belong at the MCP boundary, not in the model. So that's a key thing to keep in mind, that all enterprise policies should be at MCP boundary. Model is not what is supposed to handle that. Otherwise, it defeats the purpose for a model. I mean, another way to keep or simplify this is just keep this one basic rule in mind. Model is reasoning and protocol is enforcing. So that's why these securities boundaries should be at MCP level. Okay, talking about Azure API management. So far we have talked about MCP, but how do we implement MCP within Microsoft tools or within Azure? So MCP is what we have seen so far is it standardizes how agents use tools. But how do we run them safely at enterprise scale? So this is where Azure API management or APIM comes in. So APIM is that enterprise boundary for MCP servers. That's an easy way to define it. MCP standardizes how agents are talking to tools, and APIM is governing how those tools are being exposed safely. So APIM is providing credential and identity management so that every agent or model call is authenticated, authorized, and auditable. APM is also providing that out-of-box protections, such as rate limiting, throttling, and quotas. And finally, APM also provides unified access control and controls what can reach enterprise systems. So it provides centralized policy enforcement, logging, and monitoring. And some of these I will demonstrate in my demo in a few more minutes. So to summarize, MCP is defining the protocol, and then APM is enforcing or it's enforcing those protocols or the rules. Okay, moving on. Now that we have established APM as that control plane, let's discuss how MCP servers are created, exposed, and consumed in practice using APM. So everything you see on the left here in this slide, it already exists in most enterprises. I mean, these are the backends that are deployed behind Azure API management, and then APM becomes the single front door. So be it REST APIs, functions, logic apps, so all of this, or a lot of these are already existing, and we are putting them behind our APM. And from APM, within APM, we are doing the APIs. That's where the APIs are being governed, secured, observed, and reused. And then APM can then expose APIs as MCP servers or endpoints, turning these APIs or existing APIs into agent-ready tools without doing any plumbing. So APIM is what is enabling or giving you the capability to take these different options on the left, and it gives you that capability to expose them as MCP servers. And this is where we also apply policies. So within APIM, policies are applied, and they're applied before tools are executed. And this can include authentication, authorization, rate limits, validation, and logging. So all of that is controlled within APIM. And after policies are enforced, APIs are surfaced as MCP tools, which are now discoverable, reusable, and safe for agents to invoke. Let me see what else we have here. So APM can also register external MCP compliant servers. So thing to keep in mind is you cannot just expose existing tools as MCP compliant servers. You can also take third-party or custom tools and expose them as MCP servers. So APM gives you that capability as well. All right, with that, I will move on to my demo. So I think enough talking. Now I would like to show you how MCP works in the real world with APM. I mean, that's our central gateway to create MCP tools. And I'll show you both. There would be two parts to this demo. One with Microsoft Foundry. So that's the UI. And I'll show you once we create an MCP tool, how we can consume it within Microsoft Foundry using the UI. And I'll also show you how we can consume it within code, which I'll run using VS Code. So let me bring up my browser. Okay. Right. As I mentioned earlier, so APIM or within Azure portal. So this is my Azure portal. And as you can see, this is one API management service that I've already created. So this is going to be your interface to create APM services, and within APM, you can create API. So I'll show you. So once you have created an APIM service, go under API. So this is where you can consume existing API services or create your own. So there are multiple ways you can create or expose different APIs. As you can see, you can create it manually. You can expose them using WebSocket, GraphQL. What I'm going to use here is I'm going to use an open API specification. This is probably the easiest way you can bring in an API or expose an API using APM service. So I already have the API that I'm going to expose here is OMDB. So this is an open source movie database that's out there. Anybody can uh, go to this site. All they need is your own API key. And once you have that, you can use this API and expose it through the different tools. And I'm going to expose it through our API service. So what I'm doing is I'm not going to manually create it. I mean, that's always an option to make things easier, and this is always the best option. If you can get an API specification file, which are typically JSON files, you can import those using this option. So I'll just go to full interface. I'll say select file. So I already have this API file. And you give it a name. I mean, all of these values are coming from the API file, but you can change these to your liking. I'm just going to keep the default values here. So the display name and the name that the actual API is going to be called with, which is OMDB's dash API. I'm going to change the URL scheme to HTTPS. And then this becomes the URL for this API, but one thing I'm going to add here is I'm going to add a suffix to it. So now this is the full URL for your API. I'm going to leave the rest of the values blank here and say create. So what this does is, and let me also show you the API just to give you an idea of again. So this is how the API file or that API specification file looks like that I just imported. So it has all of these values here. But what I'm importing here is just one method. It can have multiple methods. I mean, that's what typically you would see in API specification, multiple methods. What are the security schemas and all of that information. And then within these different methods, what are the parameters? What are their data types, and all of that information will be included in these API specification files. So I have imported it, just one method to keep things simple. What this method does is it's what I'm calling it's a get title method, which returns the most popular match for a given movie title. So that's what I'm going to demonstrate here. You can go to settings and see these are the different settings for our API. I'm going to turn off subscription required. And there is one more thing I'm going to add here is, so it already has these two query parameters. So what this API is expecting, so T is the title of the movie and Y is the year. So if there are movies out there with the same name, like multiple movies in different years, so you can also send an year argument to it. But another thing this API needs is an API key. I mean, that's how it identifies that it's you who is using it. So for that, what you can do here is I'm going to add a policy. And if you go to this interface here, there are multiple policies that you can define for an API. And this is what I was talking about in one of my slides earlier. There are multiple things you can set here. You can filter IP addresses. You can limit rate by specific keys. So this is how you can set limitations for different keys. If let's say you have different departments or different teams using this API, you can set those by specific keys. So there are multiple other things you can set here. You can set caching, but what I would like to do here is set a query parameter. So this is where I'm going to pass it my API key, which has been provided to me when I got access to this OMDB API. They give you your own key. So that's what I'm going to add here. I'm going to call it API key. And this is how it's going to refer it. And this OMDB API key is actually a named value pair that I've already defined within my APM service. Uh, so this is one safe way to define your keys. I mean, you don't want to hard code them in your API files or anywhere else. So I've already defined it as a name value pair, and this is how it's being referred. It's called OMDB API key. So that's what we are putting here. Now, if you look at this code, all it says is, so this is the policy file for this API. And what we just defined is that there is one query parameter we are going to pass to this API when our tool makes a call, and it'll be picked up from our name value pair, which is referred to as OMDB API key. All right. So now that we have defined or created an API for our OMDB query or API, next step is to create the MCP server. So we'll go to this interface here, and you'll see two options. First one is expose an existing MCP server. So this is if you have, let's say, a third-party MCP server, and there are a lot of tools or services out there, and you can use some of those to just play with. I will try to demonstrate one of those APIs that TomTom exposes. So that's the GPS company. So you can use any of those API MCP servers. So they've already created their own MCP server and exposed those, and you can bring those in here. But in our case, I'm going to use our API that we just created for OMDB, and that's what we are going to expose as a new MCP server. So this is what we just created. This lists down all the methods or API operations that are part of that API. So I'm going to add this one. This is the only operation we have. I mean, there are multiple operations that this API exposes, but I'm just keeping it simple with one operation. Let's call it OMDB. I'm going to call it MCP, OMDB MCP. You can give it a description, leave everything else blank, and hit create. And it's just that easy. So we created that API earlier to expose MDB service, and are using that API, we just created a new MCP server, which is being exposed at this URL. So this is how you create an MCP server within API management service. And using some of these tools that I was showing you earlier, you can define multiple policies. I'll give you another look at it again. So these are the policies So this is where you can define multiple policies to keep things secure or limit rates, things like that. All right. Now that we have created our MCP server, I will move on to Microsoft Foundry. So this is the second part of the demo where I would like to show you how easy it is to consume or talk to that MCP server we just created within Microsoft Foundry. So this is my sandbox. I already have a project created within it. What I'm going to do now is I'm going to go to the build interface, and this is the new Foundry interface. I don't know if you guys have looked at the new interface. I mean, it was announced at Ignite last year, and since then it is being rolled out to all the companies, all the organizations. So I'll go within the build option, and then within that, I'm going to go to agents. And this is where I will say create agent. And I'm going to call it movie info agent, create. I already have this model exposed. I mean, you can create your models here. I don't know how much you've played with this interface, but you can create different models. I already have a GPT-4o model exposed. That's what I'm going to use for this agent. So going here, it's using GPT-4o. I'll give it some basic instructions. Let me just copy from my notes. So I'm telling this agent that you are an agent that provides movie information using an OMDB MCP tool. Now, where is that tool going to be integrated? So this is the interface. You go within the tools option, add a new tool. So these are some of the tools that are already configured within, I mean, these are pre-canned tools that are already there within Foundry, but in our case, we are going to go to custom. We'll hit model context protocol, hit create. Let's give it a name. So in this case, I'm going to say OMDB MCP server. So this is the name for our MCP server. Endpoint is what we got from our APM service. So this is the interface or the URL that you see here. So this is the URL for our MCP server. That's what I'm putting it here. I'm going to say unauthenticated because we already have defined our API key within API interface. So we are not going to provide anything here for authentication. All right, say connect. So what you have seen so far, we created a basic agent, we gave it some very basic instructions, and we have connected it to our MCP server tool. And let's give it prompt. Let's say, give me information for the Inception, one of my favorite movies. Let's see what it does. You'll need to approve. I'll just approve all tools. Okay, so what you see here is, and as you can see at the bottom, and you can also go to debug, when we give our agent a prompt, it's the model or the LLM within it automatically decided that, okay, for this information, it needs to go to our MCP tool that we just defined. So that's what you see here. It's sending that request. You can see that in the input, and then this is the output it received back from the tool. And that's what you see here. It provides you all of these details on the plot, cast, awards, etc. Let me give it another prompt. Give me Star Wars Year 1980. As you know, there are multiple Star Wars movies. So I'm just telling it, give me the one that came in 1980. Okay. See, I don't see it as using the tool. So give me 1 second. What I need to, and this is where you can do some of the configuration to make sure that your LLM is able to deduce smartly that these are the requests it should be using the MCP server for. Because unless you set very specific boundaries for your LLM, it can also it can skip the MCP server, it can skip the API, and it can try to get the information by itself. What I'm going to tell, and this is something you can do within the tools, I'm telling it, hey, this is a tool that you can use from my MCP server. So let's try the prompt again. So with that small configuration, now it's able to smartly deduce that, okay, for this particular prompt or for this particular query, it can use our MCP server. So that's where it's sending out the request. And in this case, it also decided that as there are multiple Star Wars movies, it is also sending along with the title, which is Star Wars, it's also sending the year value to the MCP server, which then goes to the API and it returns you the output. So this is how you can create an agent within Foundry interface and do some of the testing for your APIs and MCP. Now let me move to the second part. I know we only have 10 minutes left, so let me quickly go to my VS Code. And what I would like to show you here is, so I have a very simple MCP agent, a test agent that I've created. If you see, there's not a whole lot to it. All it's doing is using our APM interface to create or call our MCP server. So all of the instructions you would see here, this is what you see or what you saw in the interface earlier that we did in Foundry. Now you're giving those similar instructions within our agent code. And I've kind of hard coded a prompt already here. So I'm just telling it, hey, give me information about the movie Inception. Let's see. And I'm going to run this agent. And it requires very simple configuration. I have given it my project endpoint. I've told it which model to use. And this is where you see, in fact, I need to change. And this is the URL for our MCP server. So those are the basic configurations that we need to provide to our agent, and it will take those and hopefully run. And that is the error because I had the wrong API, MCP server URL configured in my requirements, in my environment. So I had the wrong value there. I just fixed it. Let's try it again. Give it a few more seconds. Looks like it's working this time. Yeah, and here it brings the information about movie Inception. So similar stuff, just within code. What you saw earlier was within Foundry, which is the UI, and this is how you can invoke our MCP server within your code. very simple to write or create an agent, and then within that agent you can invoke any MCP server that you have created from your APM service. So that's what I wanted to show you for the OMDB tool. And just to show you one more example here, if we go back to Microsoft Foundry, go back to our agents, let's say save. So what I just showed you is where we created a new movie info agent, which used the MCP server that we had created from our APM service. But I also have, let's say you want to use an existing MCP server that third parties have exposed. So there are a bunch of those. I would like to show you this one that I'd mentioned earlier. So TomTom Maps, they have exposed their MCP server that you can utilize. So I already have this agent. As you can see, the instructions tell it, hey, you're an helpful assistant with access to TomTom location services for some of these operations that it can do. I've already added my TomTom Maps MCP server within tools. So just another example. With this tool, there are some limitations. It does not let you go outside of Europe. So any prompts that you give it, you have to use. And I don't know, when I spun up this MCP server, it imposes some limitations there. So I would try to use US locations. It won't let me. So I'm just going to stay with some Europe locations. So I'm asking it what are the coordinates of this particular address in Amsterdam, which it returns. I'm going to give it another prompt. And as you can see, you can go to debug. It's using the MCP server, which is TomTom Maps. That's what it is using to get you this data. Just another prompt here. So these are different methods or different tools exposed by this MCP server. So one is where it returns the coordinates. The other one, which I'm trying to invoke with my second prompt here, is what's the fastest route? And it'll tell you the distance and the travel time. So just wanted to show you an MCP server that is exposed by a third party, and there are a bunch of these out there. I'm also trying to create Spotify. So Spotify also exposes their MCP server. They expose their API, which you can use to create a sample out of. So that's the other thing I wanted to show you, but they had added some restrictions. They had closed their interface. They only opened it back, I think, earlier this morning. So that's I would have loved to show that, but couldn't. I think this should be, or this should give you a good idea of what MCP is and how easy it is to create it within your interface, Foundry interface, and within your code. So that's all I have to show. Let me know if there are any questions. I'd love to answer those. I think we still have, what, 3 minutes?
Yeah, a couple minutes left. We've been having some chats in the chat window here, just about agents, multi-agents, MCPs versus skills versus tools, and then accessing a Mathematica system from the agent stuff. So great conversations. I mean, great presentation, Jay. I really appreciate you bringing this today. Does anybody have any last minute questions? If not, if you think of anything after the fact, I put my contact info in the chat window for dsharp@imog.org. Don't hesitate to reach out to me if you want the recording from the day. Ping me and I'll make sure I get that to you also.
Awesome. And thanks. Yeah, I see, Derek, you've already answered, provided a lot of responses. So thanks.
Yeah, just some fun
that.
conversations in the chat window there.
Cool.
Always like the engagement. So with
Awesome.
that, not seeing anything else. Again, thanks, Jay. Awesome presentation. And we'll everybody have a few minutes back. Thanks, everyone.
Thank you.
Thanks, everyone.
That was great.
Thank you.